For this video, we have the integral of 1 over the square root of 80 plus 8x minus 16x squared. What procedure should we use here? Could be a standard use substitution. Could be a trig substitution if we had that radical in the numerator. More likely, when we have a radical in the denominator, so we have integrals involving inverse trig functions. So we have this formula here. If you have the integral of du, now again, u would be a function of x in most cases. Could be just a plain old x here. This is just dx and a squared, some number squared minus ax squared. We go directly to this result. So we're looking to put it in this form. It has a radical, so we can look at the first one or the third one. Du, integral of du over the square root of a squared minus u squared will equal to arc sine or the inverse sine of u over a. So square root of whatever that is u, and the square root of this is 16, for example. This a would be 4, and so on. So I think it's going to be number 1 is the one we want to look at. So these type of problems involve completing the square. So I'm going to look at the radicand here, and I'm going to write this as 80, and then I'm going to write this as minus 16x squared plus 8x. 80 here. So this will be 80, and I'm going to factor out a minus here from these two terms here. So it'll be minus, and then parentheses 16. This will be 16x squared minus 8x. Now let's see if we can complete the square on this here. What can I put over here? Let's look at the expression 16x squared minus 8x. Can we complete the square on this? Let's see, if we put a 1 here, what does this factor into? Would that be 4x minus 1 squared? If I square this binomial here, 4x minus 1 squared, it's the 4x squared, which is 16x squared, and then it's minus double this product here, so 4x times 1 times 2 is 8x, and then the 1 gets squared, we get this. So we completed the square on this. The only thing is I changed the problem, because I have a minus 1 here. I just put in a minus 1, so if I do that, I have to add a 1. So let's do it this way. I added a 1 there, so I'm going to add the 1 to the 80. That's 81. And then this will be minus, and then I write this as 4x minus 1 squared. That's the same thing as what I have under the radical there, the radicand. Because 80, 81, and then there's a plus 1 and then a minus 1. It still gives me the same thing. So remember, the formula we looked at involved the u. I wanted to look a squared, the expression under the radical was a squared minus u squared. So I'm going to let u equal to 4x minus 1. So du would equal to the derivative of 4x minus 1. Well, the derivative of 4x is 4. Derivative of negative 1 is 0. So this is just be 4. And of course we have the dx. So let me rewrite this in that form. So this is the integral of, this will be the square root of 81. This is 81 minus, and the 4x minus 1, that's the u. So it's a minus u squared. And in the numerator we have dx. We want to transform this into an integral involving the variable u. So we can't have an x or dx. So here, I have a dx there. If I divide through by 4, this would cancel here, and by 4 here. So dx can be du over 4. So this will be du over 4, or I can put the 1/4 over here. And I got there. So let's look at the formula. Here it is here. Remember, the constant can be out here. So we're just looking at what's in the integrand here. So it's du, integral of du over the square root of a squared minus u squared. Tells me that the answer to that is arc sine of u over a. So it's the square root of the u squared and the a squared. So from here then, all I have to do then is say, okay, this is equal to, according to that formula, will be 1/4. And the sine inverse, or that's the same thing as arc sine of u over the formula. This would be your a squared. Of course, this will be your u squared here. So it's arcsine, 1/4 arcsine of u over a. So in our case, the a would be 9 squared. Okay, but the u is 4x minus 1. And that's over a. In our case, again, 81 is 9 squared, so a would be 9. And then it's plus the constant of integration. So in order to solve this particular problem, then we had to use the method of completing the square. We had to complete the square of this radicand right here. So this is your final answer. Thanks for watching. We'll see you next time.